Welcome back, Transformation Unit Part 2. In this part we're going to be multiplying and dividing our functions, and what that's going to do is going to either stretch or compress them vertically or horizontally, which is going to alter the shape of our parabolas or cubic or absolute value functions. So it's going to make them skinnier or wider. When we're working with multiplying and dividing, remember, terms that are grouped with x produce horizontal change, so that's going to affect my horizontal x-axis, and terms that are grouped with y are going to produce vertical change, which is going to be your y-axis, your up and down. In this part, multiplication is going to indicate a compression, and division is going to indicate a stretch. So therefore we're going to have four possible things. Number one, we can have a compression on the horizontal, which is going to squish our functions so that they are skinnier. Two, we might have a vertical compression, and that would make our functions wider. Three, we might have a horizontal stretch, which would make our functions wider, and we may have a vertical stretch, which would make our functions skinnier. So there's four possibilities that we're going to be working with here. Let's take a look at some horizontal compressions. If you have the normal parent function y equals x squared in red, and you horizontally compress that, means you push in from each side, that's going to make your function skinnier, and that's the blue one. So the red one moves to the blue one and becomes skinnier. That's a horizontal compression for a parabola. Same thing happens for absolute value. The red is the parent function, and when you compress it horizontally, it makes it skinnier, and the result is the blue. Here's your cubic function, and again, the red is your normal parent function, and when you compress it horizontally, it squishes it, making it skinnier, and your result is the blue. Okay, here's some vertical stretches. Y equals x squared, parent function in red. If you now stretch it, so taking kind of the tips of the red and the bottom vertex, and if you're pulling it in opposite directions vertically, that's also going to make it skinnier, so it produces the same result as a horizontal compression. Not exactly the same, but for the most part has the same effect. Same thing for the absolute value. I stretch it vertically, it becomes skinnier from red to blue, and the cubic function produces the same result. Horizontal stretches are going to have a different effect, and here's an example for y equals x squared. The parent function was in red again, and if I stretch it, that means I'm pulling each side horizontally in opposite directions. That's going to make it wider. Same effect for absolute value, and same effect for cubic function. So horizontal stretches make the functions wider. A vertical compression is going to produce the same exact result. Excuse me, not exact, but for the most part the same result. So y equals x squared, if I compress vertically, I'm squishing it from top to bottom, that red parent function is going to become wider. Same thing for absolute value. The red parent function, when vertically compressed, is going to become wider, resulting in the blue. And same thing again for y equals x cubed. So those are some basic stretches and compressions, and stay tuned for part 3, where we will actually be looking at compressing with some numerical values.